Hi everyone, today we will be presenting on the topic characterization of occupational exposure. This presentation is prepared by our group members Stanfi, Kalista, Fatina, and Afan.
Before we begin, let me introduce our group members. First, we have Stemfi Ajik Anak Lintau. Next, we have Nadiatun Afani binti Muhammad Akhir. Then, we have Kalista Ariana Majawin and Nur Fatina Ainsha Shariman. Each of us has contributed to different parts of this presentation, and we are excited to share our finding with you today.
What is characterization of occupational exposure? Characterization of occupational exposure is the process of assessing how workers are exposed to harmful agents in a workplace. It starts with identifying the type of hazard present, such as chemical, dust, noise, or biological risk. Then it looks at how this hazard enters the body, whether through breathing, skin contact, or other means. The assessment also includes how often the exposure happens, how long it lasts, and how strong or concentrated the exposure is. It considers what tasks or activities cause the exposure, how many workers are involved, and what protective measures are in place. Finally, the exposure levels are compared to legal or recommend limit to decide if they are safe or need to be controlled. What is occupational exposure definition? Occupational exposure in a medical context refers to the contact with potentially harmful agents that occur as a result of one work. This could include physical, chemical, or biological agents. For example, a healthcare professional may be exposed to bloodborne pathogen through a needle stick injury, or a worker in a lab may be exposed to hazardous chemical.
There are four main types of workplace hazards we need to be aware of. First off, we have physical hazards, which come from physical agents like noise, heat, radiation, or vibration. These can cause harm without any direct contact. To control them, we use PPE, engineering controls, and enforce exposure limits. Next, there are chemical hazards, which involve harmful substances entering the body through inhalation, skin contact, or ingestion. Examples include solvents, gases, dust, and heavy metals. To stay safe, proper ventilation, safe handling, and chemical substitution are essential. Moving on, we encounter biological hazards, which come from exposure to viruses, bacteria, and molds, like hepatitis B or tuberculosis. To reduce risk, we rely on immunization, good hygiene, and PPE. Then, there are ergonomic hazards, which arise from poor workplace design or bad body mechanics. This includes repetitive tasks, poor posture, or heavy lifting. To manage these, ergonomic redesign, proper training, and job rotation are key. By understanding these hazards, we can apply the right controls to protect our health and safety in the workplace. There are four main routes of exposure. Let's begin with the first route, which is inhalation. This involves breathing in harmful substances like dust, fumes, vapors, or gases. To prevent this, ensure proper ventilation, use respirators, and monitor the air quality. Next, we have dermal or skin contact. This occurs when hazardous substances like solvents or acids come into contact with the skin. To reduce this risk, wear gloves, protective clothing, and apply barrier creams. Moving on, the third route is ingestion. This happens when hazardous materials are swallowed, often due to poor hygiene or eating with contaminated hands. To stay safe, wash hands regularly and avoid eating in work areas. Finally, there's injection. This route involves sharp objects like needles or glass breaking the skin and introducing harmful agents. To prevent this, practice safe needle handling, use sharp containers, and wear appropriate PPE.
Now, let's look at how we conduct a risk assessment. This process involves four essential steps. Number one, identify the hazard. First, we determine what hazard exists. This can be physical hazard, like continuous exposure to loud machinery, anything over 85 decibels. Biological hazard, such as contact with blood samples that may contain viruses. Number two, determine frequency and duration. Next, we assess how often and how long workers are exposed. For example, a lab technician may be exposed to chemical fumes for 4 hours a day, 4 days a week. A welder might work 8-hour shift exposed to welding fumes. Even office worker with poor posture can face continuous ergonomic risks. Number three, measure intensity of exposure. Then, we measure how intense the exposure is. Examples include noise level measured at 95 decibel using a sound level meter. Dust concentration in washroom. Formaldehyde levels or hand-arm vibration from power tool. Number 4, evaluate health risks. Finally, we evaluate potential health effects. High noise level can lead to permanent hearing loss. Inhaled dust can cause respiratory disease or even cancer. Continuous ergonomic strain can lead to musculoskeletal injuries. Once we've identified risks, we use exposure assessment tools to measure how much of a hazard a worker is actually exposed to. There are two main types. Number one, workplace air sampling. This method measures the concentration of hazardous substances in the air. The goal is to understand exposure to dust, gases, vapors, or fumes. For example, air samples from a paint factory can be tested for toluene levels. Real-time air sampling pumps are used to capture data. A test might show benzene's level at 2 ppm, exceeding safety limits. Number 2, biological monitoring. This involves testing samples like blood, urine, or breath to detect how much of a substance has entered the body. It's especially useful when chemicals are absorbed internally. Some examples include urine tests for mercury in lab stock, blood tests for lead in battery factory workers, and breath tests for solvent exposure in industrial cleaners. These tools help ensure that both the environment and the workers' bodies are monitored for harmful exposures. In addition to air sampling and biological monitoring, we also use indirect methods to assess exposure level. These include number one, job exposure matrix. A JEM is a database that links job roles to expected exposure based on historical data and scientific research. It's especially helpful when direct measurements are impossible. For example, pesticide sprayers are assumed to be exposed to organophosphates. Metal machine operators are likely exposed to cutting fluids and fumes. JEMs are also used in research to compare exposure risks across different jobs. Number two, worker survey and observation. This method uses questionnaires or direct observation to understand how workers actually perform tasks, their use of PPE, and any risky behaviors. The goal is to identify hidden or underestimate exposure. For instance, surveys may reveal improper respirator use. Observation could show that a chemical handler leaves containers open. These insights help improve safety training and workplace policies. Together, these tools give us more complete picture of workplace exposures, even when we cannot measure them directly.
So now, let's talk about how we can control or reduce occupational exposure. Basically, there are a few main ways to do this. First, we have engineering controls. These are things we can add or change in the workplace to make it safer. For example, is using a good ventilation system to keep the air clean. Next are administrative control. This means setting rules or schedules that reduce how long or how often workers are exposed to certain risks. For example, as rotating shift or limiting work hours in high-risk areas. Then, we have PPE or personal protective equipment like gloves, masks, and boots. These are the things workers wear to protect themselves, especially when other safety methods aren't enough. And finally, we also need training and awareness program. These help workers understand the dangers around them and teach them the right way to protect themselves. So, all of this together help create a safer worker environment. In conclusion, characterizing occupational exposure is a critical step in safeguarding worker health and safety. It allows employer to identify potential risks, implement appropriate control measures, and create a culture of prevention in the workplace. By doing so, organizations not only protect their employers but also comply with legal health and safety regulation and promote long-term operational efficiency. Remember, when it comes to workplace health, prevention is always better than cure. That's all from us. Thank you. That's all from us.